is solving by factoring, which once you learn how to do this is going to look super familiar to something that we've already been doing. So our steps, just as we've seen in our last two videos, are written here at the top. We want to start to solve by factoring by setting the equation equal to 0. Now, sometimes if you take a look, example 1, that's already been done for us. But if you look at the other 3 examples, we're set equal to a number or potentially to another polynomial. So if that's not already done, we need to move everything basically to one side, subtract or add it to the other side. The other thing I want to draw your attention to is the tip here. Make sure your squared term is positive. One thing that we get in the habit of doing is making sure we move everything to typically the left-hand side. If that's not going to make the x squared term positive, I wouldn't recommend it. I would move everything to the right, and then you can always flip the equation around at the end if you need to. Once you have it set equal to 0, then and only then you'll be able to factor. Last step is the part that's going to look very familiar, and that's where we divide the factors up and set each of them individually equal to 0 and solve, hence solve the equation by factoring. So let's take a look at our first example. We have the quantity 4x plus 5 times the quantity x plus 1 equal to 0. So this one is already factored for us. It's already set equal to 0. So really, we just need to do step 3, which is literally tear each factor apart. So 4x plus 5, we can set that one equal to 0, and we can set x plus 1 equal to 0. And then we just solve individually. So we'll subtract over the 5 here, divide by 4, we get negative 5/4. Here we'll just subtract the 1, and we get x equals negative 1. And what I'd like you to do when you're presenting your answers is just put them together. So x equals negative 1 and negative 5/4. So answer number 1. Both of those, if we plug them back in, would give us 0 as the solution to that equation. Now, number 2, step 1, we have to do this time. The 5, or the negative 5 rather, is not 0, so we're going to have to add that over. So it'll still be x squared minus 11x, but now we can add 5 to 19, and we're looking at plus 24. So now step 1 is done. We have it set equal to 0. Step 2 is to factor. So we've got a trinomial, so I'm going to bring out the x, 24 in the top, negative 11 in the bottom. So what two numbers would multiply to a positive 24 but add to a negative 11? Negative 3 and negative 8. I'm going to do the factoring work over here, so we have some space on the sheet to write out our answers. So x squared minus 3x minus 8x plus 24. Remember, we do the grouping technique with trinomials, so we can take out the x for this one. We can take out a negative 8, so we get positive x and negative 3. So these two will match for us, and then we get x minus 3, x minus 8. Perfect. So factored x minus 3, x minus 8. Step 2 is done. So now we just set each factor equal to 0 and solve individually. So here are our 2 factors set equal to 0. Add over the 3, add over the 8 for this one. So my final answer is going to be x can be either 3 or 8, and it will make this original equation equal to 0. All right, let's take a look at examples 3 and 4. So for number 3, again, we have to start by getting the equation equal to 0. So I'm going to start by adding over the 7. So still 7x squared minus 14x, but now we have plus 7 at the end. Step 2 is going to be to factor now that we have it set equal to 0. And if you were thinking at all about all of these 7s and the fact that 14 is also divisible by 7, I'm going to start by taking out a GCF. that'll eliminate the numbers that I have to work with in the x games when we do the trinomial factoring here in a minute. Don't forget that this ends up being a +1 here. We can't just get rid of that term, so be careful there. And now when I do x games, I only have to worry about a 1 on the top and a -2 on the bottom. Before, I would have had to work with 49 and -14. So taking out the GCF simplifies this process right here. So two numbers that multiply to 1 but add to -2. Two negative ones will get that job done. So rewriting just the trinomial, I'm going to ignore the 7 for a minute. We'll come back to that. But x squared minus 1x minus 1x plus 1. And then we'll do our grouping technique. So x comes out of the first one. And the second one, let's see, we're going to need a negative to come out so that the signs match. And I'm going to put a 1 here since we don't have any other number to take out. But then we'll get x minus 1. And again, these two match, so we did our work correctly. X minus 1 and x minus 1. So back to the original. 7 is the GCF, and then we get the factors x minus 1 and x minus 1. Now, step 3 is to set each factor equal to 0. Well, interestingly enough, the first factor is 7, which doesn't actually equal 0. So that one doesn't give us a solution. However, x minus 1 equals 0 and x minus 1 equals 0 do give us a solution, but it's the same. When you add over the 1, it doesn't matter which one you use. It gives us the answer of 1 for our solution. So I'm going to box in one of those, and that will wrap up example 3. Now, example 4. In this case, this is more so talking about the tip here. You want to be careful about which way you're moving things around. I want to keep this 5x squared positive, so I'm going to bring these two terms to the left. And as we continue to do more problems in the later lessons, you're going to see this style of questioning where there's things all over the place and you got to pick a side to bring everything to. So in this case, I'm going to add over the 30 and subtract over the 11x and rewrite. So 5x squared will stay the same. When we subtract over the 11x, we'll get negative 55x. And when we add over the 30, we get 150. And now all of that is equal to 0. Again, you should notice here that everything is divisible by 5, so I'm going to take out a GCF to start. And what's left over is, again, a trinomial. So we'll put 30 up top and negative 11 on the bottom. Two numbers that multiply to 30, but add to negative 11. Negative 5, negative 6. And we do our trinomial / grouping work to get this thing factored. So x is the GCF of the first two terms. And the second two, 6 for sure, but to get the signs to match, I need to take out a negative 6. So then I get positive x and negative 5. Again, those match. So x minus 5, and then the other GCFs go together, x minus 6. So now we have GCF of 5, and then our two new factors, x minus 5, x minus 6. All still equal to 0. And again, we just split them up and set each one equal to 0. The first one, that GCF doesn't really give us anything because 5 is not equal to 0, so no solution given there. But these second two will definitely give us some solutions to work with. So add over 5, add over the 6, and I'll write that as one statement that x can be a 5 or a 6, and that will get our equation to equal out.